Interstellar interloper 3i Atlas just passed by Mars, but we can't see it. But we have instruments on Mars, but NASA shut down the best instrument we can't see, and we won't be able to see it that well from it. Why can't we see it? Because of the sun. So all kind of interesting things can be going on. What could be happening? What is it we may not be seeing? Well, my friends, this is a peculiar object indeed, this interstellar interloper. And what we're going to talk about and cover here is 7 anomalies that are associated with this that don't make any sense. And some of the strange improbability probabilities of it. And we're going to talk about some of the things that a lot of people are saying that just ain't true. We're going to debunk some stuff. We're going to talk about where it's from. We're going to talk about a little bit about stars and planets out there and how you can see it. But the really crazy things is these 7 anomalies. And we're going to start with the best one and end with even the better one. And the total improbabilities of this, they're off the charts. You won't believe it because I've done some calculations. Even Avi Loeb has it done. So buckle up, Buttercup. Here it comes. Guys, the first strangest thing about this, and now Avi Loeb did find this, is it appears that this object, 3i Atlas, came from the same region in the sky as something called the wow signal. This isn't the biggest wow. In fact, it's within 9 degrees of where the wow signal came from toward the constellation Sagittarius, which is where the center of the galaxy is in constellation Sagittarius, by the way. Yeah. Oh, the wow signal, what is that? Well, that happens to be the sole signal that kind of qualifies like it might be an alien signal. This is why the guy who actually recorded saw this in the transcript of the signals from the Bighorn audio telescope, radio telescope, wrote wow on the note. And it's stuck with it. It's been called the wow signal ever since. Why? Because it was transmitted for like 72 seconds and was very intense. So intense that they believe that if it came from, out in interstellar space, that it would have taken the energy of harnessing an entire star to send a signal that strong. Now, if it came from 3i Atlas or something close to it, which we'll go in more detail on a little bit later, it would have only required the power of about a gigawatt or a nuclear reactor, which, if it were a technological object, yeah, you could expect it would have one of those, right? Or a companion object might. And maybe that's the reason for that little bit of angular displacement. Maybe something else was signaling 3i Atlas. We say maybe. Now, we're about to get into these anomalies before we go into them, though I should add that the astronomer community is thoroughly convinced it's a natural object. Avi Loeb is saying, yeah, probably, but possibly not. So the probability is that it's a natural object, but it's not impossible that it's not. I just did a video on this channel not long ago talking about this object as a how it could have been achieved technologically, let's put it that way, with something called the Ensman drive. And the reason I brought that up is there is conventional technology that was conceived back in the 1960s that we could achieve. Humanity could achieve this level of technology for interstellar travel. It doesn't go faster than light. It's not Alcubierre drive. It goes, warp speed. This is conventional propulsion, just using particle accelerators to get a whole lot more acceleration. It can be done. So technically, it could be done. And just a little bit more of the backdrop, if you think about the Fermi paradox, Enrico Fermi, asked the question back in 1950, he kind of did the mental math, said, hey, given the age of the galaxy and the number of stars like our sun, about a billion, there should many older than the sun. By now, there should be, just going through all the Drake equation stuff, they should be everywhere. A civilization should be able to travel at sublight speed from star to star to star once it develops, and the entire galaxy should have been colonized. So why aren't they here? So now, if you back that up, it doesn't have to come from Earth-like planet. If indeed civilizations have been out there, it could have come from some other nearer star that's not so Earth-like. But there may be Earth-like. The fact, in the direction of Sagittarius, is at least 16 Earth or candidate planets that could support life. Maybe somewhat Earth-like, just not around sun-like stars. But there are also sun-like stars. We're going to go into this a little bit later. There are sun-like stars, sun-like, that we don't know if they got a planet or not. I'll go in more into that, but in the same direction. So there's prospects. There's prospects. So just with that background and the background of it could technologically be done, we can't say absolutely that it's not technological. It's just not probable, but it's not impossible. Okay. So now we're going to talk about these anomalies, which is kind of hard to explain with conventional comments. And the first one is the proximity of the wow signal. And the wow signal, like I said, isn't the biggest wow in this story. Not by a long shot, because it's not the most improbable one even. So Avi Loeb thinks that the probability of it coming, from the improbability of having these two things come from such close coincidence in space is like 0.6%, or like 6 in 1,000. Because 1% is 1 in 100, but this is a 0.6%. So that's pretty low. That's not the lowest thing we're going to talk about here. Not by a long shot. Anyway, and the other anomaly is the mass. Now, the mass of this thing seems to be rather incredible because it is exuding matter. Right now, they believe it's sending out about what's leaving the surface of this object is about 150 kilograms per second. That equates to 330 pounds per second, which is enough that it should put a thrust on the object itself. Now, a comet typically has these kind of things, jets that spray out stuff, and that's what forms the coma, the gas cloud around it that supports formation of the tail. Now, in this case, in the case of these comets, these things do cause non-gravitational acceleration because it's acceleration from the thrust of the jets themselves. So gravitational acceleration occurs because as it approaches the sun's actually pulling it in just a little bit, and it picks up speed. It gets to perihelion, which is the closest approach to the sun. And that's its fastest velocity. And then as it goes away, that velocity that picked up from the sun also goes away and goes back to its more normal interstellar trajectory velocity. Okay, and all that said, so you expect to see some perturbations, but what they're finding is very tiny perturbations, so tiny that they went back and calculated what the mass would have to be, force equal mass times acceleration. So you can work it out and figure out what the mass is. And the mass for this thing has to be at least 33 billion tons. That's the lower limit. 30 could be more. 33 billion tons, according to calculations done by Avi Loeb and his fellow astronomers at Harvard University. Nobody's really arguing with them about that. What we don't know is the actual size of it, because a comet or even this interstellar object has a cloud around it. And so it's hard, and that cloud, it grows as it gets closer to the sun, so it's hard to see through it. Although it had its cloud really early on, which is also a strange thing because it was already there when we saw it out at Jupiter, a little bit past Jupiter, and normally there's not a cloud around it because there's not enough heat from the sun. It's already had a cloud. I kind of explained that in my previous video. If it were an artificial object, well, you'd expect that. Possibly. Anyway, like if it's an Inselman drive object, maybe something to keep, to avoid, take the energy of molecules that would be hitting going through interstellar space. That's another story. But in any event, this thing is massive. Because it's so massive, Avi Loeb, he looks out at space and looks at the probability, interstellar space doesn't have a lot of material. The idea of something this massive could be traveling us through our solar system. He gives that another problem. I don't want to go through that now, but he says the probability is exceedingly low that we should see something like this within the short span of time that we got telescopes looking out into space for these kind of things. We should see, he says, thousands of smaller objects before we saw this one. We're not even going to factor that into the crazy low probability I'm going to show you a little bit later, which will make you really say, wow. And that's got to do with another little anomaly, which we'll get into in a minute. But gases. Now, here's the oddball thing. Comets are typically water ice. And so the astronomers expect to see water ice coming off the comet. And in this case, we're seeing mostly CO2. In fact, it's 87% CO2, carbon dioxide, coming off the surface of this thing. Well, that's pretty odd. And it's 9% carbon monoxide, CO. Water coming off it's only 4%, which is very low. We haven't seen a comet like that. But what's really weird is the nickel to iron ratio. Very little iron and a whole lot of nickel. And of all the cosmic objects we know, the nickel iron ratio's got a lot more iron in it. Nickel iron. In fact, the only cases we know of where you see higher concentrations of nickel is in manufactured objects. That's not saying that it is manufactured, just like the guy from History Channel says, I'm not saying it's aliens, but nickel is highly used in alloys and things like rocket engines. And when you fire a rocket engine, the nickel goes out into a cloud around, behind it, around it. So, and it can be used maybe in structural elements, maybe some heat shield stuff. I don't know. But it's just really strange that we're seeing so much nickel. So that's the fourth anomaly. The fifth anomaly I'm going to talk to you about. I'm not sure my 7 anomalies are exactly the same as Avi's, but it's green. Greg, comets are green a lot. Yeah, because it's normally C2 gas, carbon-carbon atoms. But it ain't got no carbon-carbon we're detecting. So we do not understand why it's green. Like my room. We don't understand that. It's strange that it's green. Like my shirt. So we do not know this. We do not understand it. It's not the carbon-carbon. The other comets like Swan, which is coming also into view in the too distant future, we don't get it. And a sixth item is polarization. Well, that's polarized. Now, light has, it travels in a frequency, but what you got alternating in this frequency is you got electric and you got magnetic. They're, out of phase. They're like this to each other, cross product. And so you got on one axis the magnetic and another axis the electric. It could be this way or this way, but they are perpendicular to each other, like 90 degrees out. So this is an odd thing that we're seeing polarization coming from this object. You would expect a spherical comet or object like that. Well, just a comet, random polarization. Having spherical does match, a geometry like that would match polarization actually, but we've never seen this in a comet. It's negative polarization. So we've never seen this in a comet. So that is another little strange thing about it. That could be an artifact of the gases coming out, the jet that is spewing stuff out. So, but the oddest of all anomalies is its approach. The fact that it is coming on the same plane as our planets. Now, see, our planets revolve around the sun in something called the plane, the ecliptic. Let's imagine this asteroid's the sun and this moon is tinier moon for some reason is a planet. Well, they all at different planets are going around in the same plane, like a dinner plate. And they're all on that dinner plate. But, if you look at space, we've got a whole 360 degree in 3 different dimensions. So something could come in from below and above. That's what you normally expect. That's what a Mao and Borisov did. They came in at different angles. But this thing is coming in within 5 degrees of our plane of ecliptic, which is tighter than your Kuiper belt objects by a long shot. So this is rather strange. And Avilob says the probability of that is 0.2%, 2 in 1,000. But what's even stranger that he did not calculate, that I've calculated, is the probability of its arrival being such that it comes in close to Mars, very close in this case, comes in close to Venus, and passes out close to Jupiter, and avoids Earth, an inhabited technological planet in our civilization. The alignment of it is very, very, very odd. Now, if you take the first two combinations, if you could add up the or multiply the probability of it coming in from the vicinity of the wow signal and coming in at the plane of the ecliptic, just these two together give you odds of 1 in 83,333. I calculated out. All you got to do is multiply the numbers. That's easy. The tough one to calculate is a probability of it coming in at such time it can make close approaches to Mars, fairly close to Venus, and Jupiter, while avoiding view of Earth at this time, while Earth's on the other side of the sun. That probability is crazy low. Crazy low. It it is more like in the range of 0.005 to 0.30 in the 5. Now, if you factor all these probabilities together, the overall probability of these three improbable events all multiplied to each other is like 1 in 1.67 billion. Now there's you wow. Yeah, 1 in 1.67 billion, or just 6 times 10 to the minus 8%. That's a percent, you got to divide that by 100 again, right? So you can say, 6 times 10 to the minus 10. Oh, that is exceedingly improbable, yes? That is strange. Yeah, and it's just kind of interesting that it's coming when we can't see it, closest to Mars. But we got resources on Mars. Yes, sir. We got things that can look out and see it on Mars itself. Yes, that's the good thing. We have the Mars Express. We got ExoMars, but most importantly, and the best instrument out there is the Mars Reconnaissance Orbiter's telescope called HiRes. It's got a camera called HiRes. High resolution. Looking down at Mars, you can see something the size of a football field. But looking out to this comet, 1 pixel, what's within 1 pixel at the distance the comet is from it, is 30 kilometers. So the entire comet, or whatever the interstellar interlocker is, may only be within 1 pixel. So all these people talking about, we're getting a picture from this thing. No, you'll get data. But we haven't got it yet. Why? Because NASA shut down. Now, what's the probability of this thing being scheduled when NASA shuts down? Well, I'm going to get into that. I got to put on my tinfoil hat, right? This tinfoil hat ain't got a tinfoil to be that wild. Nah, that's just happened, okay? No way somebody from sending an object in from thousands of light years away would have figured that one out. But anyway, it just so happens that is one of the coincidences. We got to just ride up as being, it is what it is. It's random. We hope. Wow. But anyway, guys, this is really wild. We can't see the comet well. It's not entirely behind the sun, but the sun, the coma around the sun is so bright, you really can't see it now. As a matter of fact, we're not going to be able to see it on Earth until early December. But we'll get into how you can look at it later. So that approach is really nuts. So, but the next thing I want to talk about was debunking stuff. Now to set the precedents, there are all kind of claims out there that this thing is pulsing. It's got a pulse of 1 in 17 minutes. It's got a pulse in 1 in 14 seconds. Different YouTubers are claiming different things. Now, some of the people that look at this stuff says, well, this either originates from AI hallucinations or they're just trying to get views. I think it's the latter, because I've seen videos where people come out and they're saying that, well, NASA's panicked and this lab has seen this, and they'll throw up a data chart and say this astronomer discovered this and this one discovered this, and here's the frequencies and here's this and here's that. I've seen videos trying to go into great detail. Only problem is it's all bunkers. Bonkers for bunkers. No, that is a bunch of Bravo Sierra. Not true. The funny thing is that they're trying to show one person, and they show different image. One of these channels show like 2 different images of this one person. They weren't the same people, so they messed up a little bit. They messed up a lot, because they're just, some channels are just trying to get views, and they put out anything. There's some websites that fall for some of that too, and maybe some of them are doing the same thing. But the data, we don't have that data yet. If we did, Ivy Loeb would be all over it, believe me. he would be yelling from the rooftops. So no, we don't have that data. There's also claims that it's not rotating. Actually, it is rotating, which is what you would expect. But it's not tumbling. No, comets don't tumble like a Mau Mau. Mau Mau was kind of a cylindrical object, and it was tumbling. And then all kind of stuff. Now, for something that long to be in a tumble and to hold together, I don't think it was a icy comet. I think it'd fall apart. But anyway, so Mau Mau is kind of a strange object. Borisov, no, that was definitely a comet. But this object here, it don't fit for a lot of reasons. So where is it from? Where is it from? Like I said, it's from Sagittarius. It's, like I said, there are stars out there where it's from that are quite interesting. So, like I said, we'll see it again in December. Let me see if I can find it. And when we do see it again, it'll be 1.8 astronomical units, or 270 million kilometers, about 170 million miles from Earth. It's not going to hit Earth. So if you hear anybody talking about that, they're just talking bonkers. They don't know what the heck they're talking about. Now, as I mentioned earlier, this device, this telescope running the SWEEPS survey, which is the Sagittarius Window Eclipse and Extrasolar Planet Search. That's the SWEEPS. Don't you love the acronyms? It has actually found 16 candidate planets out in that region of space. Now, they haven't confirmed all these yet. Now, there's a lot of candidates. We know a lot of planets for sure. So these still lack a bit in the area of confirmation. But now these are mostly around red dwarf stars and stuff like that. But there are some like stars out in that direction towards Sagittarius. They say there's actually several of them. There's one of great interest, which is called 2MASS 1928-2640-123. Well, that one is just a mere 1,800 light years away. So if you were traveling from that object at a small fraction of light, it'd take you a little while to get here. Even if, 1/10 of the speed of light, we'll multiply that, would be 18,000 years journey. If it's traveling close to the speed of light, a little faster, but you're not going to get too close to the speed of light without a lot of problems, taking a lot of energy. So it might get launched in the time of Christ. But anyway, we don't know of a planet around that star yet. It's a sun-like star. Now, we're finding most of these stars do have planets. Now, what we're finding mostly in planets is around red dwarf stars. We have found, and I've covered, I think, one or two instances of a Earth-like planet around a sun-like star on this channel. I think one I haven't covered yet. But we've found a very few of these, less than fingers you got on one hand. But the reason for that is it's easier to find a planet going around a smaller star because it goes around faster. So these red dwarf planets, stars, the planets going around them rotate faster. So they eclipse the star more often. And when you have an object going around another object, they actually kind of co-orbit the center of mass between the two. The star is the heavier one, so it perturbates a little bit, but not as much. So it'll actually move a little bit in response to the planet going around. Now you got a bunch of planets. It's kind of perturbating a little bit according to all these different planets going around it because they all move in concert with the center of mass of the entire system. I think it's complex of multiple planets, but that's another way to detect a potential planet going around a star. But the best way is this occulting thing. If it's passing, of course, that means that the plane of the ecliptic's got to be in view of Earth to get that kind of advantage. And you're not going to have that with all the stars. If it's going around this way, it's not going to occult. By occult, I mean pass in front of and dim the star just by some tiny fraction. So that is something that's harder to detect with like a sun type system where the planets are way out there. It takes a lot longer. And see, they don't just do it on one pass. It takes several passes for you to figure out how often this is occurring, to get the period, to get the confirmations. And so, for the most part, astronomers aren't looking at those yet. They're mainly focused on the low-hanging fruit, the red dwarf stars. That's easier to find planets on. Let's hope that that changes pretty soon because the real interesting stories are going to be Earth-like planets around sun-like stars. That will be coming, and we'll get more of that in the near future. But in this case, for this planet, a star, two mass, 192819822-2640123. Yeah, anybody lives there, they're probably not going to call it by that star name, are they? Like our sun, is that what they call our sun? In any event, uh, yeah, we don't know in that case. We just don't know yet. Maybe there's somebody will look now, spend a little time on it, find out. There's something come from there. But like I said earlier, due to this Fermi paradox situation, my friends, it might be that, if there is a civilization hopping across the galaxy, they may have outposts all over the place. And they may have it on rogue planets between the stars. They may have them on, we don't know. We don't know. Any star out there, any planet, any O'Neillian space colony around any kind of star or interstellar interlocutors may just be homes, in and of themselves on their own right. Of course, it would be if you were on a long-term journey like that. So it's hard to say. Chances are again that and astronomers around the world pretty much agree it's a natural object, just a strange one. That's the probability, according to them, but it's not improbable. When you start looking though at all these improbable anomalies, you figure the odds of us seeing, and there's some factors I hadn't even put in this. There's other improbable factors, like some of these other things we just mentioned, like what it's outgassing. If you really factored everything up, it's like we shouldn't be seeing this thing. That's basically what it boils down to. We shouldn't be seeing this thing, especially right now. But one in 1.67 billion. Now there's a wow. Coming from the vicinity of the wow signal. That's another wow. Oh yeah. But the wow signal, let's talk about that just a little bit. The wow signal happened to be at 1420 megahertz, which is in the L band, the same as the communications satellites. So we have it geosynchronous. At least that's one of the dominant bands they use to downlink to Earth is L band. It's a very prominent frequency coming from geosynchronous satellites. So a geosynchronous satellite is a satellite. Most satellites go around Earth real fast, especially from low Earth orbit, like the space station. You orbit the Earth about every 90 minutes. But the higher the orbit, the longer it takes to get around. And so at 22 to 23,000 miles out, you orbit once every 24 hours. So what that means is if you put a satellite in geosynchronous, which means synchronized to Earth, your orbit is the same as the rotation of the planet. So you look up, that satellite's always directly overhead. And we like that for a lot of our communication satellites because you can point an antenna and it's always there. It's not moving. Geosynchronous. So that is an important thing to know, that the L band is what we transmit down now. This is kind of a sidebar, but the L band, or in this case, 14 point, let's see, 1420 megahertz is the wavelength is 21 centimeters. That happens to be what's called the small hyperfine transition line for hydrogen. Now, what you get that is this is the nucleus of a hydrogen atom, and say this is the electron spinning around it. If an electron spins, if the electron flips, it emits a photon. It emits that photon at 21 centimeters wavelength, or 1420 megahertz. So that means that this is what hydrogen always does. And it just happens that frequency, the universe is pretty transparent. We're able to map hydrogen and the shape of basically the structure of the universe at that frequency. It was also suggested by Carl Sagan a long time ago, maybe others, that that would be the frequency that if any civilization was trying to signal another, that they would use. And it was recommended if we were going to try to signal another civilization to use that signal. I think when Arecibo sent this signal out, which it probably shouldn't have, that was a frequency used probably. I'm not sure about that 100%, but that was what Sagan was recommending. Now, this problem with that is that if you're transmitting with that signal, you're telling everybody where you're at. But we've kind of sort of done that, at least out 80 light years out as of now, because that's when our big radars were turned on this planet, which is probably the first thing anybody could detect. So it a fair distance, military radars. So yeah, we've had RF going out since the 20s, and before the big radars were turned on in World War II. All that said, so getting a signal from that frequency is kind of suggests that maybe somebody was trying to signal someone or us. The other side of that is what a lot of physicists think happened was to create a signal of that power. They think a magnetar, a big magnetic neutron star called a magnetar, might have sent a flare out, equivalent of a solar flare, just far more powerful, into a hydrogen gas cloud and excited it enough to create a signal that strong. So there's a natural explanation for everything that we see in astronomy so far. It can be explained away with a natural explanation. A lot of improbabilities really do stack up. Yes. So what is it with this object? It's really, really odd. So, and we can't see it. Now, if it is a technological object, while we can't see it, it could be dislodging probes going to Mars, coming on their way here, and we can't send them. It could be tiny little probes. A civilization with enough technology to send out a giant interstellar object would definitely have mastered nanotechnology. So they could send out stuff that we wouldn't see. And maybe they would be objects that would, be self-replicate, get on a planet and make their own devices and make their own machines. It could be a seed. Maybe planting a garden for something else to come. And that something else could have been something else that may have transmitted toward 3i Atlas. Maybe that's why there's a little bit of a displacement, 9 degrees, or maybe 3i Atlas maneuvered. But anyway, not now. When that signal was received on Earth was 15 August 1977. At that time, 3i Atlas, if it was going at the same velocity it was going at when we first observed it, would have been about 600 astronomical units out. It was basically already coming into our outer solar system. The Oort cloud goes way out, far beyond that. And then, the Kuiper belt reaches out a good distance. So it was already on its way in. Maybe something was given in a fine-tuned correction command. So maybe this is just the first of two. Yikes. Now that would be concerning. So if it is sending out probes, that would be we may not know it. If this nanotechnology, this thing could just keep going on. We'd have no clue. It could pass out of the solar system and go, boy, we're glad that's gone. Too bad we didn't get a better look at it. But if it slows down, if in early January we're not seeing it yet, closest approach, like I said, occurs on the 19th of December. And if you want to see it, look in the constellation Virgo. And so the comet will be moving through Virgo and into Leo, constellation Leo, the lion, in December. It will have a magnitude of 13.6, which means extremely dim. The bigger the number, the dimmer. So you won't be able to see it with your naked eye, unfortunately. But if you have you can see it with an amateur telescope as long as you have an 8-inch telescope, like an 8-inch reflector, an 8-inch mirror on it, which is pretty common in amateur telescopes. So if you got an 8-inch telescope and you point it in the right direction, you can see it. We hope, unless it's slowed down. And I'm not really looking to see that happen. Now, it could break up. A lot of comments on that closest approach to the sun. That's when they're under the max stress, the max heating they'll get from the sun. They gas out a bunch of stuff, and sometimes they break up. That's usually something passing a whole lot closer to the sun than 3i Atlas. It's still going to be a fair distance away, but yeah, it will still be under max stress at that point. So if it's going to break up, if it's really a cometary type object, which are dirty snowballs or sometimes maybe rubble piles, then that's where you expect a breakup to occur. If it breaks up, it will still continue traveling. All these pieces will still continue traveling around the center of mass of whatever it is that's breaking up. And at the speed it's heading, you'd still expect it to go out of the solar system. So, unless it's sending probes. So the prospects for anything coming back at us are pretty low. Now, if it were a comet that were bound to our sun and orbiting and breaking up, some of that stuff could stay in our inner solar system and get us eventually. Maybe not right off, but eventually. So, but that's not going to happen with this object. It shouldn't directly impact us. I say shouldn't. If it's a non-technological object, there's nothing to be worried about. And the chances are that's what it is. So I hope I gave you some good ideas, but mainly I discredited a lot of the Bravo Sierra that people are putting out, claiming, well, there's signals coming from it. Claiming, well, we haven't even listened. Avi Loeb wants somebody to listen to see if there is a signal from it. Nobody's been listening because they're getting, there's nothing. There's no point in that. Why would we do that? Oh, Lordy. Yeah, he's been begging some other guys with radio telescopes. You need to listen to this thing. Listen. So they've not done it yet. Now, maybe somebody will listen to it. Maybe they'll hear something, maybe another wow signal, but maybe not that powerful. So there you are, my friends. High res. No, there's people already claiming, oh, we got a picture of it now. We got this picture. We did see a smudge from it on the Perseverance rover on Mars. But just just a little smudge. I mean, nothing's got the resolution to look at it from Mars better than high res. And even then, it's probably going to be, if it's 2 pixels, that means this thing is really large. It'd have to be over 30 kilometers in size to fill 2 pixels. But there's a lot of data in that pixel in terms of the color that we can make a lot of determinations about this object from. It ain't going to be exciting, probably, unless the data has got something really strange in it. So then there's instruments that can do spectrographs. There's various instruments in orbit around Mars, and there'll be instruments also, Juno, which Avi Loeb wanted NASA to send chasing after this comet, and NASA's not inclined to want to do that unless they discover something unusual. So I think it goes by Jupiter and March or something like that. So chances are it's this thing just going to go out of the solar system. We're going to say, wow, I wish but they had something that could have intercepted it. But maybe it intercepts us. This technology, I doubt it. So, in any event, my friends, I just wanted to paint this picture, and I wanted to let you know that the things about this thing are strange. It's really uncanny. It's really improbable. So, why does it matter? Well, 3I Atlas isn't just a comet. It's a time capsule from another star system. Formed perhaps as far back, if it's natural, which we think it was, 7 to 14 billion years ago, older than our own solar system, older than Earth, carrying chemical fingerprints of a distant sun and its planets, maybe. And by studying it, we're peeking into other worlds' building blocks, uh, learning how different or how similar they might be to our own. Of course, mysteries remain. There'll be some things we'll never know. Why is its orbit aligned with the plane of the ecliptic of the planets going around the sun? Why is its mass so large? Like I say, most scientists see all this as having natural explanations, but what are they? That's even more important to know. But, others whisper about wilder possibilities like Avi Loeb. Is it aliens, probes, galactic debris with a purpose? Well, regardless of the answer, one truth is certain. Our solar system isn't isolated. It's part of a galaxy teeming with wanderers, some of which occasionally pass by, reshaping what we know about the universe. And the big picture is this. The last time a comet may have changed everything on Earth, it froze mammoths. Yeah, 12,500, 800 years ago, caused a younger Dryas. Yeah, their tracks wiped out cultures, you know, like the Clovis people. And for that, we call it the forgotten apocalypse. But this time we're watching with telescopes instead of Clovis points, stone tools. We're not as helpless as witnesses. There wouldn't be much we could do anyway, right? But we're looking as curious explorers. Better the look, the better, right? And the good news is, unlike that object that hit the Laurentide ice sheet and precipitated the younger Dryas on a really bad time on Earth, 3I Atlas won't strike us. Nope. But it will leave us something just as powerful, a reminder that the universe is vast and alive with full of cosmic surprises. So when you look up at the stars tonight, remember, sometimes they don't just twinkle. Sometimes they come visiting. But maybe we should keep an eye out just in case. This thing is just planting seeds in case it's got a follow-up or two. I read Rendezvous with Rama. I just did compare Mau Mau with Rama just because of this long, kind of cylindrical looking geometry. But my friends, whatever the case is, we live in curious times, and maybe we're just fortunate, especially with all these improbabilities, to be alive at such a time that such an object is passing by, and at a time that we also have the technological capability to be aware of it. I just wish we had the technological capability to send something out and really investigate it. Because we may never see this again in the entire remaining time our civilization might exist. But I hope that we will live long and prosper. So, but the bottom line is space is interesting. And the more we learn, the more interesting it's going to get. There's a lot of wonders to see in the stars. And sometimes they come right here. So, my friends, always keep looking up. Subscribe, bang the bell, and click all. Greg out.